Thanks for having me today, everyone. As Lewis said, I'm Polly. I'm from the Greater London Authority. I'm a project manager in the climate adaptation team at the GLA. I'm going to be talking today about the Climate Resilient Schools programme that I've been working on for the last 18 months or so. And so this is a programme with a partnership between the Mayor of London, the Department of Education and Thames Water. It's a £1.5 million programme that all those were funders for. And you can see there's these 4 strands to the programme that I'm going to go through in detail in this presentation. We worked with 95 schools across London. If you go to the next slide, you'll see a map of the schools. We had about 75 primary schools, with the rest being secondary schools. We covered 25 out of the 33 boroughs, and we didn't pick these randomly. These schools were picked based on risk and climate change risk. So we used the Department of Education, their surface water flood risk mapping and data, but we also used the GLA's climate risk maps, specifically the heat risk maps. So if you move to the next slide, I can show you what that looks like. So this is from the GLA's climate risk maps. There's a link there at the bottom to access the mapping if you want to have a look at it, but you can see how the schools align with high risk areas of overheating. If you pop on to the next slide, please. So as I said, I'm going to go through each one of these kind of strands of the programme and what we delivered. Firstly, I'm going to talk about the suds rain planters. If you go into the next slide, I've got some images and videos and quotes on the planters. So we installed 564 of these planters across 72 out of the 95 schools. So we didn't manage to get them into all 95 schools for various reasons. Some schools just didn't want them. Some schools, a couple actually already had some. Some schools didn't have external downpipes that we could fit them to. And I think one school had listed downpipes, so we couldn't put them on that either. So they, as you can see, they sit at the bottom of downpipes, collecting water from the roofs of the schools. The soil obviously absorbs the rain and slows the flow down into the drainage system, reducing surface water flood risk in that area. We installed an average of 7 to 8 planters per school. We could have had a maximum of 10 to 12 in each school, but the average was about 7. And we've done some monitoring on this, which I'll go into a bit later, but you can see at the bottom middle photo has got a solar panel, which I'll go into the monitoring a bit later on and how we assessed the success of these. And if you go to the next slide, please. Yeah, the next part of the programme were the Smarter Business Visits by Thames Water. Thank you. This was all done through Thames Water. So they have a Smarter Business Visit programme where they go out to businesses, including schools, to look at reducing leaks, increasing water efficiency within the buildings. So 32 out of the 95 schools had already had Smarter Business Visits in the last couple of years, so we didn't repeat that. But we got an extra 28 schools to have Smarter Business Visits during the programme timeframe. We got some good amount of water savings through those 28 schools, as well as, and that's not just the water saving, you've got the cost saving, but also the carbon saving as well. And they've got some stats on the screen there that you can see. So 1 Olympic swimming pool saved of water per week in those 28 schools, which is really quite significant when it all adds up. Next slide, please. The next part of the programme was the education and monitoring, which I mentioned a minute ago. So we've got a network of weather stations on these schools that we put in. And you can see that first photo is a picture of a weather station. They're called free stations. We worked with a company called Ambiotech, who work with King's College London on these weather stations, and they're kind of low cost, almost kind of DIY weather stations that can be made to measure whatever you want, basically. But we're measuring rainfall, temperature, humidity, wind, and various other parameters as well. So the reason we put these weather stations on the schools is because we've got the soil moisture sensors and the planters, which I mentioned, and we've got a soil moisture sensor kind of deep down at the bottom of the planter and then one more towards the surface layer. And we can use the data from those soil moisture sensors along with the rainfall data collected from the weather stations to determine how effective those planters are at holding and storing water during rainstorm events. Yeah, there we go. We've got some photos of the weather stations and the soil moisture sensors in the bottom left photo. You can see there's two probes, and we've got 30 planters have the soil moisture sensors in. Thank you. And then we've also got the education part of the programme. There's kind of 3 strands, and this is ongoing. We're still working with the schools on this. We have kind of a basic poster where the children can go out. They obviously can't go and like kind of stand next to the weather station because they tend to be on roofs and things like that. But they can go out, have a look at it from the playground, and see what the different things are measuring. They've also, each school has an individual data dashboard where they can go in and have a look at air temperature through a week or over the year, and plan classroom activities around that. And that goes with these geography lessons and maths lessons and physics lessons inserts as well, that the teachers can use with the free stations as well. We're also developing in-classroom hardware demonstrations for the schools, so they can kind of have the weather station in the classroom to go through how it all works as well. And with the monitoring, we're going to keep the soil moisture sensors in until March next year, so we'll have a full year's worth of data, and we're hoping to keep the weather stations on for at least 3 years so we can get some good climate data across London. So on to the next part of the programme is the climate adaptation plans. If you go to the next slide, please. First, I'll go through the climate adaptation plans. We did 60 bespoke plans for 60 of the 95 schools. Those are the only ones that wanted them. The rest didn't feel like they wanted one. And they have this, they're really quite detailed. There's an example on our website that you can go take a look at. We've got information about the kind of the building construction type, and some information about the risk of overheating and of flood risk as well. And if you click on the next, yeah, and then we've got some the bespoke information about the climate change impacts and risks, and these were done with surveys. So Arup, who conducted this, they went to each of the 60 schools, spent a few hours at the schools with the teachers, with the caretakers, with the facilities managers, asking them questions about their school. Where were the flooding hotspots? Where were the overheating hotspots? And where were the kind of water scarcity issues in their school? And they did this all on ArcGIS survey. So they had a phone or a tablet, and they could input all the information on there, and it will be uploaded automatically. If you click on the next bit, yeah, and then we've got a this is part of the plan as well, and you can see there's we've kind of suggested measures that they could put in to reduce those risks. We've told them, you know, I've highlighted what the risks are, but we've also given them solutions that they could potentially implement to reduce those risks. Click on the next slide, please. And so what did Arup find? We have an overview report of all the 60 climate adaptation plans to kind of bring us some good data and overarching stats from these plans. Overheating was the most widespread and pronounced climate change impact experienced by the schools. So over 90% of schools reported overheating as an issue, and nearly 80% of schools reported that overheating has a significant impact on student learning, productivity, or behaviour. And these surveys were done the end of last year, so the last year's heat wave was really high in people's minds still. We've got this stat of an estimated 22,000 student days of lost learning due to school closures and things like that during that heat wave event. If you click on the next one, yep. And then in terms of flooding, 75% of schools surveyed had been impacted by flooding, and we knew that was going to be high because we had picked these schools based on their risk. So we did know a lot of the schools had already had impacts from flooding, and we've got some stats there on student days lost to flooding as well. Next slide, please. In terms of the recommended resilience measures that we put in, so over 500 physical measures were recommended across all 60 schools. Roughly half of those recommended were predominantly around heat risk and addressing heat risk, so things like shade sails, window shading and things like that. Brown shade sails and linear rain gardens were the most frequently recommended measure across all the schools. And the schools, we asked the schools what they wanted, and the most commonly desired measure identified was related to the increased provision of shading, so green shade sails and things like that. Next slide, please. In the overview report, you can also see some stats like this, so the amount of impermeable and permeable surfaces on school sites, and also some indicative capital cost ranges for some of the most recommended measures. But if you go on to the next slide, there's some more information on that. So we've also got this compendium of measures that we've published. It sets out 5 categories of physical, climate change, adaptation and resilience measures relevant to the schools that we surveyed, but could be applied to all schools really. And these are to help them address the main climate change risks. If you go on to the next slide. So this is how it's laid out. Again, this is online, so you can take a look at this in your own time. We've got things like trees, green screens and green walls, and they're not all just green measures. There are some hard measures in there as well. It's got a description of the measure, a sketch, and then if you click on to the next slide, we've got some indicative costs as well, and kind of the maintenance requirements, but also importantly the co-benefits as well. So things like biodiversity, where we know the co-benefits of a lot of greening is biodiversity and carbon savings and things like that. Okay, so that's the end of my presentation, just on what's next in terms of this programme. As I said, we're going to continue monitoring the planters and up until March next year, and we're going to keep the weather stations on the schools as well. I didn't say, but all that data is open data, so it's online for people to use and download if they would like to use it. We're also looking at potentially installing some of the measures to reduce overheating in some of the schools as well. But we haven't quite decided what that looks like yet, so watch this space. Next slide. Thank you very much for having me and for listening, and yeah, I'll hand back to you, Lewis.
Thank you, Holly. Really interesting stuff. I'm sure we'll have some questions on it at the end. I'll move on to our second speaker, who is Lauren Petch from Atkins Realis. Lauren has over 10 years experience working in the water industry and has been at Atkins now since 2014. She's a proficient coder in both Python and R, and has a mathematical background, having completed a BSc in mathematics and a postgraduate certificate in applied statistics. Lauren works on many aspects of water resources planning process, including stochastic weather generation and drought assessment, climate change analysis, demand analysis, water resources modelling, and investment modelling. Today, Lauren is presenting on estimating the impacts of demand restrictions during drought. So thank you very much, Lauren, and over to you.
Okay, thank you, Lewis. Yeah, so if we go on to the next slide. So yeah, I'm going to be talking about estimating demand restrictions during a drought. And so I'll give a bit of the context there and what we're talking about when we're saying demand restrictions. Then I'm going to go over 2 potential approaches with some case study examples, both case studies of work we've done with Thames Water. So if we can go on to the next slide, thanks. So essentially, droughts are going to be more likely, probably because of climate change in this country. There's also other kind of increased pressures on demand, such as population growth, and also the fact that a lot of us in this country live in the kind of the areas that are more water stressed and are going to experience more of the issues because of climate change. And all of this means that water companies may need to call on their powers to put in demand restrictions more often. And being able to understand the savings that we can achieve from those demand restrictions is important in terms of both short-term and long-term planning. And I'll just, so I'm clear that when I'm talking about demand, it can either mean total distribution input, so all the water that's going into the system, or it can be referring to just household demand or the non-household demand with the businesses. So the distinctions there are kind of the users and whether it's you're including the leakage and the other loss components in that as well. So if we move on, thank you. And yeah, just to go into a little bit more detail on what I'm meaning when I'm talking about demand restrictions. So the water companies have the power to enact certain drought measures during a drought, and these are defined under various legislation things, primarily I think all coming from the Water Industry and Water Resources Acts in 1991, but there's been various amendments to that since then in kind of 2010 and 2011. So that these come in kind of increasing levels of restriction. So the first one, which is I don't think isn't defined on any legislation necessarily, but just basically doing an enhanced media campaign and trying to raise awareness so water companies can put that in when they feel like there's a need. Next up, you'd have a temporary use ban, and this is what was previously called a hose pipe ban, and that's aimed at domestic customers. And then after that, you get a drought order restrictions. So that's specifically, in this case, a non-essential use order or use ban. So NUB, sometimes referred to, and that prohibits or limits usage across the non-domestic demand sector. And then finally, you would get an emergency drought order, and that's where companies are restricting supplies through rotor cuts or standpipes in the street. And the last time I think that happened in this country was in '76. And I think there's a general feeling now across some companies that that level of restriction wouldn't be acceptable anymore, or at least you want to make it as least likely as possible. But as I'm sure people are aware, we've had temporary use bans in the last year or two, depending on what area you're in, and there could, depending what happens, we could end up with non-essential use bans as well.
You don't want this applied year off one, for sure.
Yes, so the tubs are focused on domestic consumption, and that's kind of hose pipe, not watering your garden, don't clean your car, that kind of thing. Non-essential use bans are targeted at non-domestic customers, and there's a set of, I think, 9 or 10 kind of purposes which they restrict, and that includes watering outdoor plants on commercial premises, filling or maintaining non-domestic swimming pools, and various other water uses there. It should be noted, though, that there's, for both of these, there's quite a few kind of exceptions. So particularly around the NUBs, the aim at least is to try and limit impact on people's businesses, but that also would likely limit some of the effectiveness of some of these measures. So there's a bit of a trade-off there. If we can go to the next slide, please. Okay, so one of the first methods when you're analysing past events is when you're trying to estimate the savings is if you've got past events, you can use them to kind of estimate how effective they were and get an idea as to how effective your restrictions might be in the future. So you can use statistical models to predict water demand based on explanatory factors such as weather, so that would be temperature, rainfall, etc. And you can use that to understand your past savings. So essentially you fit a model to your observed demand, covering periods of no restriction as well as your restriction events. And as well as your weather explanatory factors, you may have other levels of detail in there. So depending on what type of model it is, you could have things around the house type, demographics, occupancy, that kind of thing. And you also include a explanatory factor in there to represent your restriction event. It should be noted here that these are quite complex things, so there's bound to be confounding factors in there, and particularly when we're talking about drought restrictions, the impact of, say, a neighbouring water company introducing a temporary use ban before there's one in your actual area can have an effect basically on neighbouring areas, because it's not always clear where it is, and also it's just a kind of increased awareness of the issues going on during those times. So as much as possible, it's good to kind of try and analyse these, and if you can, include factors where they are significant. And then you can estimate the impact that from these demand events by looking at the sum of the explanatory factors to do with the drought restriction and the fitted coefficients, and you can convert that into a percentage impact, and then we look at kind of the estimated savings across the month and how that changes across the year. And then, so that is all about understanding the impact from a past event that we're analysing, and then you can look at extrapolating that to understand your future saving potential. So if you run those fitted coefficients, for instance, you can run those fitted coefficients throughout all your years of weather data, and then you can use that to understand the range of potential savings. And you could also, if you have it, you could also be running that through synthetic or stochastic data sets as well, not just your historical observed. Yes, if we go on to the next slide. So this is an example of looking at the Thames Water. Thames Water have implemented temporary use bans in 2006, 2012 and 2022. And so we did some work for them where we were looking at updating their demand model. So the main purpose of the work wasn't necessarily to look at the tubs, but we had to as part of the work, because there was one in 2022 and quite a recent one. So what we did is we modelled including tubs factors for each of those events separately and all together to see how they kind of vary over time. And we looked at 3 different explanatory factors. So from when Thames introduced enhanced media campaigns, when the tubs was announced, and then when it was active. And we also looked at so there is an inherent kind of time factor in there with your weather components, but we also looked at the differences between winter and summer in terms of response to the tubs. And and so what you can see from the plot there is that if you look at the difference between the red line on that graph, the red dotted line is the modelled demand if there had been no tubs introduced. The black dotted line is what was actually observed, and the light blue line is the modelled with a tubs factor in the model. So that gives an indication of the impact of the demand restrictions for that event, which is the 2006 event that is being shown there. So if we go on to the next slide, thank you. So then this is when we are extrapolating forward to get an idea of what savings might be. So we calculated the savings. So we ran the tubs coefficients through each year of the observed data that we had, and that is shown, and then summarized all the estimated savings as an average per month. And that is what you can see in the blue lines. So this shows the kind of the spread that you could get across different kind of weather conditions, because obviously if if you're in a situation where you would have been using more water, then a demand restriction is going to have more impact there. And that's why we can see that obviously there's more impact across the summer months when people are watering their garden more. And then to get an understanding from that, you want to pick something from that range of blue lines. It seems reasonable. You could take the 50th percentile, say kind of the mid-range, although it seems reasonable to assume that you're only going to be introducing a demand restriction in the years which have hotter weather. So in that argument, you might pick the kind of the 90th percentile there, which is shown in the red line. Okay, so if we go on to the next slide, now I'm going to talk about a different example. So this is where this was trying to estimate the savings that can be had from a non-essential use ban. And in this case, we don't have any past events to go from. And so we basically built up some assumptions based on the different components and brought them all together so that we could get an understanding of what the impact might be. And there were two main methods that we used for this. So the first, which was our preference method, was a bottom-up assessment, and this involved looking at all of the Thames non-domestic customer base and looking at the property types and allocating which was relevant to each of the non-essential use components, and then having an assumed percentage of usage of their water usage that would be applicable to that component. So as a kind of quite a simple example, if it's a public park, we assumed that the majority of the water they're using is for watering outdoor plants, and so is applicable to the first purpose. It's obviously not exact, but part of what we did was develop this tool where all of those base assumptions were quite obvious, and you can easily change them to kind of get an idea of what the impact is there. Where that wasn't possible, so there's a few categories where we weren't able to do that, we did a top-down assessment, which was working on what we had from high-level assumptions and then bringing that down as much as we can to the Thames region. So if you go on to the next slide.
Sorry to jump in, Lauren, just to say you've got a couple of minutes.
Yes, I think this is my last slide, basically, so that should be okay. So
perfect. Thanks, Lauren.
So then we've got the table here shows the 10 different purposes that are defined by the NUBs and what method we actually adopted for each of those. So yeah, as I said, we went for the bottom-up assessment where we could, and sometimes went for the top-down. And part of this was that, so where we did bottom-up, we were looking at their historical usage across companies, across the properties, and then we could apply those percentage savings. So part of what we also did was looking at how that changed from that as an annual saving or an estimate for summer savings against winter savings. And we also looked at the differences between across their total data set or pre and post pandemic on consumption. So yeah, I think I'll stop there. Yeah, since I was running out of time. So I think that's good. Thank you. This was just a summary slide, so that's all right.
Thanks, Lauren. I'm sorry to cut in. I'm just mindful we want to have time for all the speakers and go on to Q&A. So yeah, nicely timed in the end. Thank you. So yes, we will move on to our next speaker. Yeah, I can see people are posting questions in the Q&A, so please continue to do that. We'll answer those at the end for the ones where we've got time, and our speakers are answering some of the simpler ones as we go as well. So yeah, on to our next speaker, John Chappell from National Infrastructure Commission. John is a Senior Policy Advisor and Water Policy Lead at the National Infrastructure Commission. He's been with the Commission for 4 years and has worked on a number of policy areas, including reducing the risk of surface water flooding, building climate resilience into infrastructure systems, and speeding up the planning system for nationally significant infrastructure. And today, John is going to be talking to us about the work he's been doing on reducing the flood risk of surface water.
Thank you, Lewis. If we could skip through to the third slide. Perfect, that's the one. So just a very brief word on what the National Infrastructure Commission is and why we exist. We exist to provide the government with long-term strategic advice, independent advice on infrastructure policy across 6 sectors of economic infrastructure: transport, water, waste, digital, and flood risk management. And on the slide, you can see 2 examples of infrastructure failures, which illustrate the reason why we need to exist. The first is a mock-up of Havant Thicket Reservoir, which is the first new major water supply reservoir in this country to be built in 30 years. The second is, as you'll recognise, an Elizabeth Line train, and our view is the Elizabeth Line is not 4 years late, it is 40 years late, because the original decision to build it was postponed until it was long past needed. So that's what the Commission does. Today is a very important day for the Commission. We've published our once every 5-year national infrastructure assessment, which sets out the UK's infrastructure needs for the next 30 years. And there's a lot in that assessment, but today I'll be talking about surface water flooding. If we can move on to the next slide. And just in terms of setting out that assessment, we have 4 objectives rather. The first is to support sustainable economic growth across all regions of the UK, to improve competitiveness, to improve quality of life, and to support climate resilience and the transition to net zero emissions by 2050. And hopefully the link to that assessment has gone into the chat, as well as it's now live on our website. So what I wanted to talk to you about specifically today is our work on surface water flooding. This is within the assessment, but we published it as a standalone study last year because it was commissioned slightly earlier than the rest of the assessment. And that was in November 2021. And we were asked to focus on how we can better manage and mitigate surface water flooding with a focus on the role of infrastructure, unsurprisingly, given our role. So we were to analyse the risks of surface water flooding and the opportunities that exist to address them in the short and long term, understand improvements needed to drainage systems to manage and prevent surface water flooding in urban and rural areas, including through nature-based solutions and hard engineering, and to consider the optimum cost-benefit analysis of infrastructure options and how these can be combined to deliver greater resilience and better value for money. And when I say cost-benefit analysis, we have tried as much as is possible to put a value on things beyond hard economics. So those quality of life things, the mental stress of being blooded, all of the disruption that it's caused. So we've tried to be as all-encompassing as possible. If we could move to the next slide, please. And so the critical thing that we highlighted in our report is that as the Holly's first report on sort of flood risk management and planters in schools highlights, surface water flooding is a massive and growing problem. The number of properties at high risk, that means having a 1 in 30 year risk of surface water flooding, could double over the next 30 years, and that's because of climate change. You can see 2 and 4 degrees scenarios modelled here. Population growth, but also what we call urban creep. So that is the paving over of permeable surfaces like lawns to make way for driveways, and social change might drive that as well. So, for example, more households may want to pave over their driveways for electric cars, which they need to charge and therefore park right next to their houses. Next slide. So we then looked at what you could do in terms of investment through cost-benefit analysis, and again covering a sort of much wider than just money, the sort of social costs as well. What you could do in terms of reducing the number of properties at high risk of surface water flooding. So that's the very high risk, the 1 in 30 year risk. And basically what we found out was that looking at a 2 or 4 degree global warming scenario, at 2 degrees, you could cost effectively protect properties, about 60% of properties, and another for 9 billion, and you could do it for 12 billion in a 4 degree scenario. We opted for a 4 degree investment scenario because a lot of this infrastructure, it's a lot cheaper to build it once and build it bigger than it is to go back and have to add to it. It's, a lot of drainage infrastructure is not necessarily modular. So we thought it's better as a no regrets option, and also you would protect more properties than you would spending 9 billion even in a 2 degree scenario. So that is broadly where we are. And to give you a sense of what that means, that is a 3.6 billion increase on current baseline levels of funding. So it's not 12 billion completely new, it's assuming current levels continue. You need to add on to that across 30 years, 3.6 billion. Next slide, please. So really, the cost is not the major issue with surface water flooding. You need a bit more money, but not lots more money, because there's a degree of surface water flooding which remains challenging to address. What you do need to sort out, as the Commission recommended, is governance, because surface water flooding, water coming from the sky at too fast a rate to be taken up by drainage and onto impermeable surfaces, well, it runs into highways drains run by local authorities, which may or may not be blocked, and it also runs into water company drains. Those two organisations have a duty to cooperate, but that duty has not led to coordinated action on a national scale. There are some good local examples, but generally speaking, it has not. So that is what you need to sort out. And the way that we've said that you do that is firstly with data. The Environment Agency should improve its data identifying high-risk areas, drawing in local maps and models and not just a top-down national model, so that we can better understand where the risk is. And then, as I said, the core area here is governance. So the government should set a long-term target for risk reduction of the number of properties at high and medium risk of surface water flooding. Our modelling suggests that should be 60%, but it's up to the government ultimately to decide. It should implement Schedule 3 of the Flood and Water Management Act 2010, which means that new developments don't add to the problem, because surface water coming from new developments should go into separate drainage arrangements and not into already potentially overloaded combined sewers. This will also help with sewer overflows as an issue. Government should clarify the duties of Ofwat, the economic regulator for water, enabling water companies to invest, including in nature-based solutions, because there are sort of complex regulatory barriers. These are being addressed, but we believe all of them should be addressed. And then critically, in high-risk areas, once you've identified those high-risk areas, local authorities and water and sewage companies, and where relevant, other bodies such as internal draining boards, should be required to develop costed long-term joint plans to manage surface water flooding, including local targets for risk reduction assured by the Environment Agency with input from Ofwat. Now, that is a massive change that we are asking of government, because we are asking effectively for the Environment Agency's funding to local authorities, about 40% of current spending on surface water flooding, to be devolved to local authorities in high-risk areas to fund their share of this plan. You cannot have coordination between local authorities and water companies unless both sides can bring the funding required to the table and be sure that they're going to get it, and not be waiting on a bidding process from the Environment Agency. So that's a relatively hard-hitting recommendation. On investment, I've talked about the 12 billion, and based on the baseline, that would be 60% water company, 40% public funding, by which we mean funding for local authorities from the Environment Agency. As I've said, about 40% of properties would remain at high risk of surface water flooding, and that is because it is very, very challenging. You can only build sewers so big, and there are other engineering challenges which mean it is not cost effective to develop solutions. So what we are saying you should do is government should look at property level measures for those remaining areas once you understand the risk, because surface water flooding is not like river and coastal flooding. It comes and it goes very quickly, It is often relatively shallow, and therefore property level measures such as door guards are much more effective than they would be in a river flood, where they could cause serious structural damage to a house by keeping water out. So we didn't have time in our study to look into detail at that, but we've recommended that government should. Next slide, please. That may well be the last one. What happens next? This is the last one. So we don't just make recommendations and go away. The government has committed to respond to our recommendations by either accepting or rejecting them within 12 months. We published this study last November, so we are hoping within the next month we will get a response. And then for those recommendations that accept, every year we publish an infrastructure progress review in March, where we track whether the government is actually doing what it has said it will do. And that we will do from next March. Thank you very much.
No, thank you, John. Really interesting stuff. Thank you. And yeah, firstly, thank you to all of our speakers today for giving up the time to come and speak. We will now move on to some Q&A. So I'll invite the speakers to all turn their cameras back on. I'm going to be a little bit selfish and ask a question myself first. Chair's prerogative. Yeah, it's for you, John. In terms of those recommendations, how confident are you that the government will take up those recommendations? Do you get any inkling of that, or do we have to wait for the government's response?
Well, ultimately, I can't speak for the government, but I know at present the devolving of funding will be a serious mindset change for DEFRA, for the Environment Agency, and for the general treatment. So I wouldn't say I'm 100% confident that the government will accept those recommendations, but what I would say is if they don't, the government have to set out what they're going to do instead. And we've already seen that there is a legal duty to cooperate, which is not driving action. So I'd be very interested to see what their plans are instead.
That's great. Thanks, John. We'll keep a close eye on that one. And yeah, given my day job is in the Environment Agency, I'll be particularly interested to see what they come back with. I'll move to some of the questions that we've had come through the Q&A function. We have still got time for some questions, so do put them in there if you've still got questions, and we'll come to them if we can. A question here for you, Lauren, and this is from Louise. Firstly, she said, thanks, Lauren, really interesting. How can this information be used to plan ahead for future demand restrictions? And are there any incentives for users and suppliers to make water savings as part of their best practice?
Yeah, so I mean, I think there's lots of ways that you can look at the data from past events to try and get an insight into what has been most effective. I guess that could be in terms of periods that have been most effective. If you've got the data and the detail, you can see where restrictions are most effective in terms of the type of people in the areas. So you could use that information just to get an idea in terms of your planning to say when you're working out if their levels of service and if they've got a reliable supply, if you have an understanding of how much people are going to be saving from them. Yeah, I mean, I think there are incentives to save water. The water companies do have pressure on them to kind of be showing that they're not, whether that's enough and whether they're doing it well enough is probably a point for discussion. But yeah, there are the kind of the processes there, I think, to incentivize saving water. But yeah, I think it's possibly arguable whether enough is being done right now, and if it's being whether the water companies themselves have the most power, or whether there should be some more coming from the kind of government side of it as well in terms of that. So yeah.
Great, thanks, Lauren. Maybe the subject for a future talk. Another one for yourself, Lauren. One from William. So yeah, from William online. What is the reasoning behind changing from the self-evident phrase of hosepipe ban to the obscure use of tubs? Any rationale for that, or is it just,
yeah, I mean, I don't know
acronyms?
specifically, but I would imagine it's to avoid the idea that it just covers your hosepipe ban. So while it is predominantly kind of watering of the hosepipe in your garden or using a hosepipe to water your car or something, I would imagine it was to try and move away from that and give it this idea that it is a general kind of thinking about where unnecessary water is being used. Yeah.
It's great, thanks, Lauren. And then another question from William, actually, but this time for you, Holly. What happens to the suds planters when there is a long drought? Is there provision for watering? And I wanted to answer this one live because it ties in with a point Joe Bradley, who was presenting for us yesterday, made about sort of better designs of suds and how we account for them during drought periods, as well as during times of high rainfall as well. So what happens to the suds planters during times of drought?
Yeah, that's a good question. So we have provided the schools with kind of a maintenance, it was like an A4 bit of paper that says, you've got to, because you said they were made of wood, you've got to treat them every couple of years, make sure your guttering is kept clear, which is a big one. We did find a lot of schools didn't clean their guttering very often. But there was also information about when to water them if there is a drought in there. So it is down to the schools to do that. We have found some schools are watering them anyway, despite the fact they shouldn't need watering most of the year. Is they've got, the school's gardening club going around and they're just watering everything that they see. When that's coming through on the soil moisture sensors, it's not raining, but the soil moisture is going up. So it is down to the school to make sure they're watered during drought periods. We didn't obviously have a drought this year, so we couldn't test that. But we will hope to keep an eye on them if that does occur in the future, but when it does happen in the future. Yeah. Also,
right.
sorry to add, the plants chosen were chosen specifically for to be wet for a short period of time and then dry as well. There was also aspects of shading in there as well. So when plants are on north side of buildings, they need to be shade tolerant and things like that. So the plants were chosen quite specifically for the job.
Brilliant, thanks, Holly. A question for you, John, I think. So this is from Yvonne. Where can we get information on the government response to your recommendations when this is issued? And then there's a second question. Did you include additional costs to let me start that again. Did you include additional costs to authorities in your costings? These need additional funding to comply with your recommendations.
Yes, so we are very conscious of that. And firstly, the government will publish on the gov.uk when they so it's a public response with a formal response to every single recommendation. But that will just be on gov.uk, so that's where you'll find it. When is a bit of an open question because that's down to the government. In terms of resource funding for local authorities, we are very aware of that issue. We made clear in the report that what we were talking about was investment in capital infrastructure, but there needs to be investment in resource to accompany it, because local authorities, frankly, cannot work, even with a legal duty to cooperate with water companies, can't do so if they've got someone working on flood risk management half a day a week. So we're very clear on that, although it needs to be focused on high risk areas, which of course needs the data to highlight that as well.
That's great. Thanks, John. I've lost some of my questions. Bear with me a second. Yes, another question for you, Lauren. Are there any interesting trends in water usage? How did usage change during the pandemic? Did you pick that up through your work?
So we did slightly. There wasn't really enough time on the project to look into it as much as I might have liked to. There were some trends that would be expected. So obviously demand for non-domestic consumption went down, specifically during the pandemic. that was something that you could see continue across kind of restaurants and that kind of thing. So it did a big dip and then still hadn't got up to their previous usage. But one thing we did find, which I wasn't expecting, was that actually we were getting out slightly higher potential savings since the pandemic. And I started to look into that, and we didn't get a chance to fully kind of delve into it. There were some things that we found that were suggesting things like golf courses are using more now since the pandemic and that kind of thing, which I don't know if that's more people are into were taking advantage of getting out and have now taken up golf or something. I'm not sure, but yeah, so there's definitely more that could be done, kind of looking at that and trying to like working out, being able to delve into the different kind of usage types and that kind of thing. Yeah,
it's an interesting question, and a point that was made yesterday during some of our talks was the fact that we have had some extreme summers over the last 3 years as well, so probably quite difficult to pick out the difference between changes due to changes in lifestyle and habits and climate changes as well over the last 3 years.
I mean, I guess golf courses will have had to be watering more to keep nice green lawns, won't they?
Yeah, so could be related to either, but interesting question, so thank you for that one. And then just one last online question, again another one for you, Lauren. Links a little bit to a question I asked previously, I think, but how do you account for non-compliance with NUBs?
So that was another bit I probably didn't mention in the talk. So on top of our kind of bottom-up assessments, we also had an additional factor that was our assumption for kind of this is our high estimate of savings against each purpose and the low estimate, just to give a bit of a range there. As I said, it all is kind of just putting assumptions there, and there were some particular categories that were probably quite have more uncertainty around them. So for instance, with things like vehicle washing, we did that from a top-down assessment, and that was estimating quite a high potential saving because the increase in kind of hand car washing services and that kind of thing. But then you could argue that because of that increase and them being in kind of quite often just in bits of land and not being necessarily that official, how likely are they to follow a restriction if it comes into place? How is that actually going to be managed, practically speaking? So I think, again, if there were to be a non-essential use ban, there'd be some kind of work around that. And
that's great. Thank you very much. I'll draw it to a close then, because we're approaching 1:30. I hope you've enjoyed today's session. Thank you again to our speakers. Really appreciate your time. One final plug, we are going to be going out for new committee members for CIWEM Central Southern branch shortly, so keep an eye out for that if you fancy being involved in organising webinars like this going forward and other events locally. That would be great. And then just a final plug for our next session tomorrow, our third and final day on climate change. So join us again at 12:30 tomorrow if you can. Thank you very much, everyone, and enjoy the rest of your day. Thank you.